Good afternoon, everyone. Good afternoon, everyone. Oh, goodness me, it's been a long day. Death by PowerPoint. So I'm about to just drive the nail in the coffin over here. I'll try and go through it with some vigor. And if I get to stuff that we've already spoken about, I'm just going to flick over that slide. I'm not really going to repeat it, otherwise we'll be here for a bit too long. So let's move on. We heard this gent earlier today, and he actually coined the phrase "seek and destroy." We actually saw it in one of his slides. And really, this is a validation, scientifically validated process, strategy for ready-to-eat facilities. And effectively, what it is it's a collaborative effort, which we'll get to a little bit later, which cleaning plays quite an important part in, and we'll discuss that. So we've spoken about biofilms, and when we talk about the emphasis of my presentation to you, it's really going to be about dealing with the persistent biofilms that we get, and therefore the persistent listeria that we find in these outbreaks that we've spoken about over the last few days. And how do we deal with that? So we've seen this particular diagram, and basically it's just showing that if you look on the third particular slide, that you can actually have a biofilm build-up. You can monitor it through some sort of swabbing process, have negative result for listeria because it's covered in its biofilm, and then it explodes and the listeria emerges out and then contaminates on a mass basis in a particular harborage point. So let's talk about cleaning and sanitation and the role and impact in the seek and destroy method, removing the biofilms. We talk about what we call the sinner's circle, and what you've got in cleaning, you've got four things that are at your disposal. You've got time, and we'll talk about that. We've got chemistry, we'll talk a bit about that. We've got action, we'll discuss what that means, and then temperature of the water. Those are underpinned by three essential things: validation, cross-contamination during the cleaning process, and cleanability or cleanableness of the particular item being cleaned. So we've got some empirical evidence here, and it validates the fact that we see that the flow and the action, the temperature, the chemistry, and the cleaning regime have a positive impact on the removal of biofilms. So let's talk about time. So I've got a little acronym over here, and it's called the when principle. So when we use that, first of all, the W is when, i.e. the frequency, and we'll talk a bit about how we determine frequency. How? So the method that's going to be deployed, the disassembly that's going to be initiated, and the cleaning tools that are going to be utilized. The E is for enough, and that is the contact and the time we have to make an impact in terms of that particular cleaning regime. And then the N is no compromise. And this is quite an important principle, because this goes back to culture. And I think it's been reiterated by a number of people. But it's very easy to push the cleaning team out an hour just because you want to run up that last couple of sausages or chicken or beef or whatever the case may be. It's an easy way, it's an easy play, and it's very tempting. But we have to get into a culture of not allowing that to happen. Absolutely no, it's not worth it. And it is too frequent. Frequency needs to be validated on a risk-based view. So, frequency risk factor. I've got a little diagram here for you, which I thought was pretty useful. On the left there, you've got likelihood of a risk to food safety, large, small, very small. Moving across on the bottom axes, you've got a severity to food safety and the effect, and that will translate into the actual risk that you associate with that particular piece of equipment or area, or whatever you're trying to assess in terms of risk. And then you'll simply plot that and say, right, if it's red and it's an 8 out of 8, that's got to be cleaned daily, but it could even be hourly. It could even be, caught every sort of tea or lunch break. Again, validation, extremely important here to determine how you can effectively keep the bioload of that particular piece of equipment down, because we've seen how the bioload does increase significantly straight after cleaning and immediately into production. So again, validation, very key in terms of frequencies of these particular areas. And in some of these call it non-product handling areas, very important to have them on a structured schedule with the correct frequencies that are maintained, because these are actually the areas that become the harborage points, not so much the areas that you're cleaning all the time, unless you can't get to it. So I thought an interesting initiative was a cheese producer in Sydney, just building on what most people have been talking about drains, was actually having a drain cleaning plan. And to say, they actually map out, and they actually did a little map. They got the floor plan, and they sat there and they mapped out where are all our drains. They looked at where do those drains flow to, which drains are welded closed, which can't open, which are difficult to clean. And they had a persistent problem with product contaminated with listeria for a long period of time that just kept on repeating and emerging again and again and again, despite rigorous cleaning methods being done on equipment and in the non-product handling areas. So a couple of things were wrong. Number one, some of the drains weren't being cleaned. So in some instances, they had to be replaced with an appropriate drain that was able to be cleaned. In some instances, there was a wrong method being applied in terms of actually cleaning that drain, so that was changed with a new SSOP put in place. And then something interesting was happening, a phenomenon, not so much, but Friday evening, last intensive clean of the facility for the week, cleaning team does its bit, facility is immaculate, packs up, leaves, and on Saturday afternoon, the drain cleaning contractor comes in to do unblocking of drains with a high-pressure machine. And it was stumbled on. It was just an arrangement. It was going on as part of a normal routine maintenance function. And of course, what was happening was all of that, the stuff that was in the drain was emerging into the facility and actually contaminating the equipment prior to the startup on the Monday. They actually validated that. They did air plates and they actually picked up the micro load in the air after atomization out of those drains. So we stopped that, instituted a different cleaning regime. We put it onto a schedule so that each drain was checked as if it was a piece of equipment, and bang, Bob's your auntie, gone. No more problem. Another empirical study, which you can see, but frequency is a vital element in terms of cleaning risk. C&D routines need to be formalized. Bacteria is easier to kill before biofilm formation, and bioload increased chance of biofilm formation. So more bioload increase, more chance of biofilm formation. So let's talk chemistry. Got a term here called AA cleaning regime. Not alcohol anonymous, but it's alkali acid cleaning regime. And there's quite a bit of input around this, especially around CIP systems. But how this process works is you would take an alkaline product, preferably with some sort of sodium hypochlorite component to it. You would foam, scrub, rinse, and then you would apply a second detergent of an acid-based descaler type detergent, also foaming, foam, scrub, rinse, and then from there, after rinsing, you would then sanitize, disinfect, and dry. So key to this whole, after implementing this at an RTE Vienna plant, results indicated twice a week for the best maintenance of the biofilm. So again, validations required. How many of these cleans do you need? Not every day. Is it weekly? Is it every 2 days, every 3 days? Validation important. We introduced it at 2 times in the facility, and in fact, we saw a significant decrease in presence of Listeria monocytogenes in terms of their routine monitoring of it. Contact time is key. Foam quality needs to be at least 90 seconds to preferably 10 minutes of contact to allow your chemistry to work. Disinfection step is actually part of the UCAS scope for the ISO 22000 standard as it applies to cleaning within the food sector. So it is almost, it's the only OPRP as it applies to cleaning. So crucial disinfection step. Disinfection is affected by organic matter, so desoiling is important. Delene's mentioned and so many others. We've got to get the facility clean first and then apply disinfection, allowing it the best possible chance to work. So we looked at numerous different disinfectants that are widely available in South Africa, numerous suppliers, and we've validated them against Listeria in lab environments, and all of them were pretty much effective in those tests. Speed of kill differs in terms of how long it takes, but if you look at the EN and the SAN standard, the new SAN standard that's coming out now, they're required to achieve a log 5 reduction in terms of their effectiveness. But crucial is dosing and the verification that the chemical is being used at the specified percentages. And again, this needs to be verified before disinfection. Is the chemical at the right concentration before you disinfect? And if the dosing equipment is not dosing correctly at that time, you've got to change it. You can't just go and say, sorry, don't worry, just do it at 0.5. We'll fix it tomorrow. We've got to have that discipline of using it at the right percentages. It was just a bit of empirical studies. Right, I want to talk a bit about water pressure, because obviously cleaning with water is a fundamental aspect, especially within protein environments and other environments. And let's talk terminology very quickly, because I think it gets used interchangeably. When we talk low pressure, okay, we're talking 10 bars and below, all right? When we talk medium pressure, or medium boosted pressure, we're talking 10 to 30 bars. And when we talk high pressure, we're talking the 100, 160, 200 bars, okay? And there's a direct correlation between volume and the power. So the volume of water versus the power at which you force that water, there's a key distinction between that, and we'll see why. So the cleaning force is actually derived from how hard you can force a larger volume of water as opposed to how hard you force that water. The impact is actually more at a lower bar with more volume. You get a better cleaning impact. All right. We'll talk about the issue around atomization because of high pressure. All right, mechanical action is part of your, is a balance between time and impact, and obviously time needs to be given to have that right mechanical action. And then a huge component to a successful clean is the principle of deep dismantling. Maple Leaf had a 98% reduction in a persistent in 1 week with their slicing machine that they identified as the problem. We all know the Maple Leaf, I'm sure, case study. And introducing a process of deep dismantling, taking it down to the absolute bare bone and sorting the problem out, gave them huge success. Design and accessibility, validity of the regimes, and routine disinfection without proper cleaning leads to persistence and resistance. Temperature, this is really aimed at meat processing and further meat processing facilities. Optimum temperature is 55 to 60 degrees with the detergent in terms of giving the right speed. Superheated water kills bacteria but does not really remove biofilm on its own. And cold water is good for the first rinse for initial debris removal, which is preferable as heated water at this stage can cake or bioload on equipment. And we've seen that already today, as another speaker has spoken about that. All right, so let's talk cross-contamination, the cleaning process very, very quickly. Aerosols and the impact on food safety. So when we talk cleaning, deep cleaning gets clean and the cleaning contaminates from the bottom up. So cleaning down and cross-contamination up. So aerosols. So with a low pressure or medium pressure, you have very little aerosol. With a high pressure, lots of aerosols. There is some validation to I'll go back there. There's some validation to the amount of micro that sits in those into those aerosols and how long it takes for them to settle. If you look at this here, this is after 15 minutes, you still got 100% of the atomization sitting in the air. So you got to get that away. And that's key before you start. So what's actually happening in that potentially is that you're applying your disinfectant on your equipment, and then within 15 minutes, all the molecules that were above it now fall onto your equipment, contaminating it further. So there was the empirical research about those aerosols, and then there's another one there in terms of this one was quite interesting because they specifically looked at how Listeria was able to survive in aerosols itself. And it was prevalent and quite well researched. Going into extraction, staying there, extraction gets put on, condensation, dripping onto equipment. All right, validation. Surveillance and mapping is so important to the cleaning team. That's part of their eyes, to see where do they have to get to. So that's key, and I would suggest involving them in the results of those on a continuous basis. But inspection is, I think, underplayed a little bit. we've got to get into a process of getting our facilities as close to 100% visually clean as possible. And that is a partnership between quality, production, engineering, and the cleaning team. And I think it can't be seen as this big black stick. It's got to be seen as a partnership for food safety and scrutiny, which is good for the product, it's good for the business. So no one glove actually fits all. These are just ideas. You've got to validate your process for the seek and destroy to work. It's iterative, it's continuous improvement. So we spoke about cleanability. I'm not going to repeat it. It's really looking at redesigning and rethinking how we strip and dismantle equipment and get it down to its bare bones so we can get to every single element to clean it effectively and apply our cleaning regimes. There was a successful initiative we called the HIT team, or the High Impact Intervention Team, and that is a grouping of people that are given this role, traditionally quality and technical, to validate, survey, and to give us guidance, engineering and maintenance to help disassemble, redesign, reconstruct, and then the deep clean, or let's call it the cleaning and sanitation team, that do the dirty work, excuse the pun, provide the action, the chemistry, and the methods to get the facility to where it is. So the idea is that this team would actually, firstly, if there is a problem identified, would tackle it on an intensive deep cleaning basis and sort the problem out. But in addition, would do continuous improvement together and identify and push the boundaries of different pieces of equipment, high-risk pieces of equipment in their facilities, to push the boundaries of dismantling and cleaning, to get down to the bottom and try and identify any problem areas at the same time. Critical response to an ongoing process, and then conduct the intensive cleaning protocols. So just on that, intensive cleaning protocols for me means that the area that's a problem, where we've identified an area that has been seen to be the potential harborage point for a contamination, gets quarantined. The cleaning team goes in, and there's a protocol. They change the equipment for each stage of the cleaning. For example, the specific PPE they wear when they move in and out that facility. No one in there until they're done. Only the high impact team, accredited to go in there, conducts their business, and gets that particular area or piece of machinery back to where it's supposed to be, and then validated by QA before that particular piece of equipment can start up again. Because far too many times you see these interventions happening, and there's people walking in and out, and there's different activities going on, and that team is not conducive to a successful intervention. You want to know if it worked or not. You don't want to have variables about, is it this, is it that? You want your intervention to be validated. So key takeaways, to wrap it up. There's no single silver bullet. No one chemical is going to solve your problem. No one method is just going to solve your listeria problem. It's got to be a holistic effort, and it's got to be one that is constructive and systematic and scientific. Use the WEN principle, very key, frequencies and culture. Then use the AA cleaning regime and use the disinfection dry regime to help you get through your cleaning regimes. The HIT squad, very key initiative. Deep disassembly, seek and destroy. Validate what works for you, and management of these processes are key. Thank you.